Alrighty, calculates. This is the last section on all your crazy formulas. I hope you've been keeping up. I recommend index cards. It's the best way to help you stay on top of them. Just read them 5 minutes a day or 5 minutes in every class when you have time at the end of the other periods. Okay, so these are the integration rules when I'm going backwards. This first one, when I have a squared minus u squared in the square root on bottom, is my arc sine of u over a plus c. Note over here on the side that a is a constant, so it'll be some number squared. It probably won't say squared, it might say like 49, and you have to figure out, oh, that's 7 squared, where u is your variable. So using those as constants and variables is consistent with all the other formulas that we've already done. And then the second one, where I have a squared plus u squared, is actually the arctangent, again, of u over a. And the third one, notice this time that the order of the subtraction has switched, and I have an additional variable outside the square root, and this one is arcsecant, again, of u over a. This time u is in the absolute value. And honestly, the only way you're going to get good at these is just by doing the practice. So you're going to, hopefully you recognize, ooh, I'm going to need a lot of practice. And you probably need to write these formulas down on index cards and just cycle through them with your other formulas. These last 4 sections of chapter 5 are going to be very difficult if you don't know the formulas. So when I look at these, I'm looking for, now that I have square roots on bottom, I'm looking for perfect squares on the inside. So I have to figure out if I can write this as some perfect square. And of course I notice there's a 2 in it, so it seems like I could switch those. And of course I could write it this way. And then I have to think about which one's the constant and which one has the variable. So of course I can see the variables in this one and the constants in this one. So that tells me that this is a u squared minus a squared. And since it's not just a u right now at the moment, I want to create that so it looks like that stuff in that pink bubble that I'm circling needs to be the u. And then consequently my du is e to the x dx. Which gets a little tricky on this problem because I don't have an e to the x in here with the dx. And I can't divide by it because I don't know what x is. So I'm not sure if I'm dividing by 0, although e to any power can't be 0. But more importantly is I don't want to have an x in this when I'm about to change everything to u. So as I change everything to u, I'm going to leave this here for a second. Of course, this numerator is going to be my du, and the denominator is now u squared minus, we're going to say 1 squared. And I can't have that x in there, so I look at this and say, golly gee, what am I going to do? And then I'm reminded that that's actually u. So what I really have is du, and then a u on the outside, and then u squared minus 1 squared. And then when I go back and check to see if this fits any of the forms that I have up above, I go, oh yeah, this looks just like the third version where I have the u outside, which means this is going to end up giving me secant. So I'll have 1 over a, but a is 1. Arcsecant of absolute value of u over a, but a is 1. And here's my final answer.